Lesson 0.2, Solving Inequalities. In this lesson, we'll simply solve inequalities and graph the solution on a number line. The definition for inequalities is the relation between two expressions that aren't equal. There are several types of inequalities. You could have greater than, less than, not equal to, greater than or equal to, less than or equal to. Similar to the 0.1 lesson, I'd like you to just try one at a time. Some of these will be easier than others. Try one, graph the solution on a number line, and then press play and see how you did, and then move on to the next one. For my first example, I got x is greater than or equal to -2. On my number line, I made sure to include 0 as the kind of defined middle, and then I divided the number line evenly before I plotted my solution. Based on the fact that x is greater than or equal to -2, I used a closed dot on -2 to represent that location. Greater than means my arrow will point to the right. As you solve these equations, it's a good idea to keep your variable on the left-hand side and then your solution on the right-hand side. And then you'll know which way your arrow points. Go ahead and try the next example. On this example, I ended up with x is less than or equal to -2. As I worked through the process, similar to solving an equation, I distributed in the -4, I combined like terms, moved 4 to the other side by subtracting, and then when I divided by -6 to get x by itself, notice the inequality switched direction. Remember the rule, when you multiply or divide by a negative, you switch the sign of the inequality. Again, it's a closed circle at -2, and because x is less than that value, I now include all values on the left. Next. Our next example doesn't include a closed circle on our number line. I got a final result of x is greater than -13. I started by moving the x's to the left-hand side and then everything else over to the right. Even though the right-hand side is negative, when I divide by +2, I don't switch the sign for the inequality. Therefore, x is greater than -13. I put an open circle at that location with my arrow pointing to the right. Last one for this section. Our last example had x being multiplied by a negative fraction, -7/2. To get x by itself, I multiplied by its reciprocal, -2/7. That canceled everything on the left but x. On the right-hand side, I had to remember a couple of things. Because I multiplied by a negative, I switched the inequality, and then I simplified the right-hand side. -3/4 times -2/7 becomes +3/14. On my number line, I had to recognize that 3/14 is between 0 and 1. Because x is less than or equal to, I approximated that location with a closed circle, and my arrow pointed to the left. Sometimes when solving an inequality, you end up with a value that has infinitely many solutions or no solution. If you have infinitely many solutions, what ends up happening is the variable actually cancels out. And the numbers that are left make a true inequality statement. The opposite of that, if the variables cancel out, well, not variables, there's only one. So we'll just have one variable. There we go. Variable cancels out. But now your inequality is a false statement. So if the inequality is true, you say infinitely many solutions, no matter what value you pick for x, it would work. However, if the inequality is a false statement, then there's no solution. Let's work through these last two problems together. It says solve and graph the solution on a number line. Looking at the example on the left, I notice that there are x's on both sides of the inequality. The first thing you want to do is try to get them on the same side. With the parenthesis on the left, I'm going to distribute the negative 3 in to eliminate it. Negative 3 times 2x would simply be negative 6x. Negative 3 times negative 5 becomes positive 15. Greater than negative 6x plus 9. I'm going to move the 6x over by adding. And then notice what happens. The variable cancels out. We get 15 on the left-hand side greater than 9. Is that true or false? That's actually a true statement. Because that inequality is true, it means no matter what you plug in for x, the left-hand side will be greater than the right-hand side. So we say infinitely, whoops, if I could spell it, that would be great. I can infinitely, there we go, many solutions. I'll just abbreviate solutions. On the right, same idea, 4x minus 5 is less than 2 times 2x minus 3. Again, there are variables on both sides, so in this case, I'll distribute the 2 in on the right, giving me 4x minus 5 is less than 4x minus 6. Getting my variables to the left-hand side, I'll move 4x over. The variables cancel again, but now I have negative 5 on the left is less than negative 6. That's actually not true. If you look at the number line, negative 5 is closer to 0 than negative 6 is. Therefore, it's not less than. Because of that, this inequality would have no solution. And those are the notes for day 1 of 0.2.